Good afternoon, YouTubers. And today I'm going to be presenting to you this animation of the McCabe Runner. It is a little steam engine, very small, but it get the job done. I really like it because it's basically one piece for both the timing valve and the piston right here, and it used two flywheels and a rocker arm. And this design comes from this web page is mpmcck.tripod.com. So it's right there, and particularly there's many design here, and the one that I picked for this design was the McCabe Runner. Really like that one. You hit there, it gets you many pictures of many designs as shown here, and also include the blueprints. Excellent. And better resolution here, and you have the blueprints to create your design. Actually, I think that I have it here in let's see, better this one. And basically you have pretty much the design of the base, and the block for the doing the piston and the valve connections and everything else. Here's the rocker arm, and if you follow this, which is basically what I did, you end up with something like this in Fusion 360, and which is kind of nice. I mean, and you really from here to go, like for example, to 3D printing should be straightforward. Although I might do this in 3D printing, but instead of using this kind of design, I might go with only one flywheel, to save some PLA, and another cylinder here close by. Not this particular design, but I'm thinking about it. But let me discuss a few things here and there so you can appreciate this work of the McCabe Runner. And so this is, as shown here. Let's see the dimension of this guy. Basically, let's go this way. We are talking about basically a 6-inch times a 3-inch, and so forth. And you start to use the blueprints and get the connection, the way it is. So as always, timing is a big deal on this design, so it took me a little while to synchronize them, to ensure with this rocker arm position and everything else the way it should. Like for example, let's do one thing here. Let's get this component out of the way so you actually can see what's really happening here. I let that little spot there is there we go, is the hole between the timing of this valve and the push in and out of the piston. Let's move a little bit to the sideways so you see what I'm talking about. You see? Now the question is, let's stop this animation for 1 second and escape, and let's do by hand. So like for example, here we go. When the piston is right at the bottom, you want air to, or steam to go in. The steam will go this way. If I put this back, you see the steam will, this is the entrance of steam or air, whatever you want to use. Get that out of the way, and the valve at that point should be, or need to be, to start opening. So as soon as I move this flywheel in the right direction, this valve need to go this way. So sorry, actually it's go that way. This valve need to go down. Let's see if it's true. You see, it's going down because the flywheel, this flywheel turn clockwise. See, now what's happening there? Since air is going, or steam is going this way, now this is out of the way, and that air will start to rush in and will push the piston up. So as shown here, piston is moving up and the valve is moving down, meaning more air can get in easily. You'll take a look here. That's what's happening. Now we keep moving this guy. You get to a point. Now the valve start to close, but air is still getting in, or steam, until you get to the bottom. Now at the bottom, see, it's totally closed. Air cannot get in anymore, or steam. And in that case, what need to happen is that this valve needs to open. So this will move to the left, and in doing so, as you can see, this valve has a recess that will allow air to go through it. So air will escape, or steam will escape this way to the right. So that's how this will looks like. Let's give it more of a turn. See, now if I put this back, you will see all the time as the piston is traveling down, you can see that the valve is moving. The valve as shown here is moving to the front. So let's move this a little bit more. You can see there, until now you get to a point. Now the valve, the piston is still moving down, but the valve now is moving to the other side, trying to open the entrance of air or steam into it when the piston is at the bottom right here. So if I take a look here, see, pretty much is at the maximum distance. So let's get this, oops, sorry, that one out. You see, it's pretty much straight. So now it should be close. This hole here should be close. But it actually getting open it again, just so air can rush in again. So if I keep turning, yep, that's how it goes. Now it's fully opened, so air can get in and push the piston until the cycle repeats itself. And that's basically how this McCabe Runner looks like in this animation. The rocker arm, as you can see here, one particular and interesting issue, it is not well aligned here. I didn't pay too much attention aligning this rod here, and that creates a little bit of a problem. Because these connections are stiff, they don't bend, so you have to allow for some of those imperfections. On this particular one, it's the only one that has this kind of a different color, meaning which is a different joint. I could use any of the regular ones, but since there's a misalignment that I didn't pay attention to get it correct, as you can see here, that what it is actually, let's see it from the top. You can clearly see that it's not well aligned. These need to go out a little bit more, but I leave it on purpose. So I never, because in reality, what is happening is you definitely will have some freedom, some movement here, extra movement that will allow for those imperfections. So I think that I leave it like that, because it's a natural way that things will work in real life. So everything else is as rock solid as should be. There's no issue with the other joints. They are straight. They don't particularly are based on the rigidity of the item that you're using, or the material. They're stiff. In other words, they don't bend unless you put a joint there, and then that will follow. But on this particular one, it is a ball type of joint. Okay, so it's a little bit different, and I want to be sure that you understand that type of joint, that it is a ball. I can change it. If I change it to, let's say, to revolute, it will not work, because I don't have enough freedom on that movement, and the whole thing will get stuck. So leave it as a ball joint, and that will do. Let's say okay, and I think that's basically it. I mean, let's do, actually, to finish this, let's do a visual style. Let's do a wireframe, and if I can pick this animate model, so you can see, here's the piston, and the piston, this is the hole that I talked to you about, the valve connection, so that air can get into it if you are doing a kind of an air engine. But it could be a steam engine. I mean, everything is metal here. That looks kind of neat. I really like it. It's small enough that can be definitely something that I will do a 3D printing. I will do some changes on it. I will not use the rocker design. I will use a more solid one, more easy to deal with than the rocker. And we'll see. But I really like it. So let's do, let's see what else we can do here. Visual style. That looks better. And that one, I don't like that one. That's the normal one. So I guess that we have covered all the bases on this design, which include pretty much, it's a very straightforward. I don't use for these, I didn't use the sheet metal. I went regular solid stuff, like for this, for getting the axle and the whatever is going to be holding the axle. So I didn't use that. That's well described on the, if you go to here, that's this part here, the bearing carrier. How will you do it? So I did it based on this, but using, and so this rocker arm, I also use the regular solid design on Fusion 360. No more than that, and that's basically it. Then the connecting rod were more like, as required to get the job done. Let's see, going back again to the Fusion 360. One thing that I will say, and that's gonna be the last thing that I will say on this, is I originally tried to use enable, going through enable contact set, but the more I use it, the more I feel like I didn't like it. The behavior is kind of nasty. It is not as smooth as all when you use join. When you use contact, I don't got the right feeling. that is working the way I want it. Let's see. Let me escape from here for 1 second. Let me see if I had it here. That version is right here. Let's see. This is the version with a contact. Let me see if this is still work. Let me see. I'm not sure what stage is this guy. You see that? Yeah, it's pushing on this, but that kind of a jerking behavior of the contact really bothers me. I don't of the simulation, so I stopped there. You could use, I mean, if you like this kind of jerking, that would be okay. I don't, so that's why I stopped this design, because I thought to use this kind of a contact. I'm using an eccentric here to push on this rod that eventually will do on the rocker arm. So, but when I started the simulation, I said I don't like it. This is not good. It doesn't do a good job of when it gets to. It just do it very quickly, jump to the other side. So I don't know. Maybe I can change the type of eccentric that I use here to make it this smoother, but eventually nothing beat the other design. I really like this design a lot better, this one. There we go. Like this much better. It is smooth all over, so I stay with this design with so let me see something else. Let me see. Well, folks, that will do. As I always said, have a great day, whatever be your final destination. Bye.